Welcome back, everyone. So today we are doing day 4 of our notes. For day 3, what we looked at was solving radical equations and inequalities, specifically looking at square roots. So today we're looking at other roots, so cube root, fourth root, fifth root, things like that. And then we're going to also look at radical exponents that are mixed, or not just 1 over a number, so not 1/2. What happens when we have, say, 8 to the 2/3? What is our process there? So that's all what we're going to be doing today. So our first, what we're going to be doing first is solving a radical equation with a cubed root. So the process is actually the exact same as the square root, except for instead of square rooting and squaring, we're going to be cube rooting and cubing. So if we do this, we have to get the cube root by itself. So we subtract the 15 over, and we're left with the cube root of 15 minus square x, or 7x, sorry, equals 2. And then we're going to have to cube everything instead of squaring it, like we did in the last video. So we're left with 15 minus 7x equals 8, because 2 cubed is 8. And then when we solve for x, we get x equals 1. And you can verify this here on your own, but I can tell you that x will equal 1. And when we check, I'm going to show visually. You can also do it just by plugging in 1 into your calculator. But for the sake of the video, we have the cube root of 15 minus 7 times 1 plus 15 equals 17. Okay? So when we do this, we're left with the cube root of 8 plus 15, and that'll equal 17. So then we have the cube root of 8, which is just 2, and the rest of it. So it comes out that it is a solution because we get 17 on both sides. All right. So we're going to move on to B. I'm going to have you pause the video and work on it yourself. Once you come back, I'll have the answers for you, okay? So go ahead and pause now. So here's our solution. We have x equals 9, and I did the check over here, so we can verify that it is a solution to this equation, okay? So let's move on. We're going to look at now other rational exponents, okay? So for this first one, this is a fourth root or quartic root. You can use your calculator to check any of these, but what we need to figure out is how we can break this down into getting the fourth root. Okay? So what we need to do is, how many times do we need to group, or what do we need to have 4 of that gets us 16? Okay? So let's start by writing this as an exponent, a radical exponent. So that's going to be 16 to the 1/4, right? Okay, so our exponent is 1/4. So to figure out what we need to do from here, we need to separate it. And what we need to do is separate into 2. Start by separating it into 2. Okay? So this is our solution for this. We get x equals 9, and I did the check over here, so we know it's good. Okay? So now we're going to look at radical roots that are different than square roots or cube roots. So for this first one, we have the fourth root of 16. And just to recap what we did the other day, we can rewrite the fourth root as a exponent, a rational exponent. So we have 16. Let me redo this. So this is going to be 16 to the 1/4. Okay? So when it's a radical 4, it's 1/4 exponent. Now we can actually separate this, and I'm going to do it for this one because it's easier to show. But for any of these, you can just go into your calculator and type it in. But for what we're doing next, I'm going to do it this way. So we have this, we can separate the 1/4, and remembering our power rules, this is the same thing as 16 to the 1/2 times 1/2. Okay? So if we did the exponents multiplied by each other, or it raised to an exponent, then the exponents multiply. And if we did that, it's 1/4. Okay? So then we simplify the inside. So then we have 16, the square root of 16, which is 4. And then we're left with 4 to the 1/2 power, which is the same thing as square rooting it. So we get 2. So that's how we can find the fourth root of 16, and that would be 2. Okay? So like I said, you could go into your calculator and do the rest of these. We're going to move on right now and do this part. So what this is saying is what I just talked about, where our rational exponent with whatever a value we have, that's the root that we're looking at. So then we apply the power property as well, where we have a number raised to a power, then raised to another power, is that number raised to those two powers multiplied. So we're going to use those two properties and look at the 8 to the 2/3 power. That's kind of why I said it at the beginning of the video. So when we look at it, the expression 8 to the 2/3 can also be written with roots, radicals, and exponents. So first, let's look at the 8 to the 1/3 or 8 to the 1/3 squared. To rewrite that using a radical, we would have the cube root of 8, and all of that will be squared. So then so that's what that would look like. Then if we did the other one, we have 8 squared to the 1/3 power. And what that would look like is the cube root of 8 squared. So these look different. We have a root squared, and then we have item squared, then cube rooted. What we're going to show next is that they are actually the same. So if I solve the first one, the cube root of 8 squared, the cube root of 8 is 2. Then we're going to square that. That equals 4. Okay? Now for the next one, we have the cube root of 8 squared. When we do this 8 squared, we get 64. And it's harder to tell this one, but the cube root of 64 is going to be 4. So we can see that both methods get to the same answer. But which one do you think is easier? I would say the first one, because you're dealing with smaller values. So if we look here, this kind of highlights that even more. So if we do this method, we have to get 16 cubed and then fourth root that. Or we can do the fourth root of 16, which is 2, and then just cube that. Okay? So if we didn't have a calculator, which is this next question, I would say method 2 is the better one to go. Okay? And that's because it deals with smaller numbers. So go ahead and pause the video, and you're going to fill out this chart. So you're going to find the exponential form, the radical form, and then you're going to basically solve it. Okay? So go ahead and pause the video now. Okay, so this is the table. This is what it should look like when you've finished. I recommend pausing the video and just double checking that all your answers are right. If you have any questions on what any of the numbers are, just go ahead and ask me in class next. But this is what your answer should be. We're going to skip number 6 for now because I want to cover that in class altogether. And then 7 and 8 are just practice you can do on your own. They might become, one of them might become a warm-up question, just a little hint. But I want to focus on this last part because we are talking about exponent properties here, and these do apply to our rational exponents, okay? So we need to make sure we remember what our exponent properties are. So this first one, when we are multiplying two numbers raised to different powers but the same base, we're going to combine the base, so it's just going to be 1, or the same base, in this case it's a, and then our exponents are going to add together. So we have a to the n plus m. If you want to think about it, think of it a as 2, and so you have 2 times, or 2 to the third times 2 to the first. The 2 is going to combine here, and then your exponents are going to add together to get 2 to the fourth. So then we go over here, and this is just the opposite. We have the same base, but the two expressions are dividing. So when they divide, our exponents are going to subtract. So we have a to the n minus m. Okay, a to the n minus m. Now we've talked about this a lot today, but when we have a exponential expression raised to an exponent, those exponents are going to multiply together. Okay, so we have, let me fix that. So it's going to be a to the n times m. Okay, we go down 1. We have a times b all raised to the power n. When it's two different numbers raised to a power, the power is going to distribute to each part. So that means we're going to have a to the n times b to the n. And then just the opposite operation here, but the same concept. We have a over b all raised to n. So what we're going to have is a to the n over b to the n. And then lastly, we've seen this one before, hopefully. We have a raised to a negative exponent. Whenever you have a negative exponent, that's saying bring that number into the denominator. So instead of a to the negative n, it's going to be 1 over a to the n. So these are our main exponent rules or properties that we'll be focusing on at some point. So if you have any questions on how we get any of these, please bring those questions to class. Otherwise, do some of the problems that I didn't, or that I skipped over today on your own. But we will cover number 6 in class, and we will have covered the first 2 pages, or the first investigation of this day, prior to this video. Otherwise, if you do have any other questions on how I got anything, or anything like that, bring those questions to class or see me in your free time, and I will go over it, okay? Otherwise, I will see you next class. Thank you. Have a good one.